I'm Mrs. Kelly, and behind the camera is Mrs. Rogers. She will also be doing a commentary today.
Hi, sweet peas.
What we're going to be doing today are classification matter, types of mixtures, homogeneous or homogeneous versus heterogeneous, what those differences are. We're going to do a little bit of a review first. Let's talk about chemistry. Now, we're in physical science, I know that, but we do need to know about the applications of chemistry. Chemistry is the study of the composition of matter and the changes they undergo. Everything in the universe that matters is matter. Remember that. You matter. Matter and properties. Matter is anything that has mass and takes up space. That's even air. As long as it has a mass and it takes up space, it is matter. Oh, that made a sound effect. Isn't that fun? Matter makes up everything. And now, to go along with matter, we also have the law of conservation of mass and energy, and that states that matter cannot be created or destroyed, neither can energy. The energy that is here on Earth has always been here. We're just transferring it from one place to another. When we eat food, that energy transfers to us so that we can use it to move around, so on and so forth. But matter and energy can never be destroyed, they're just transferred. Solid is the very first phase we're going to be going over. Next up will be
State of matter.
State of matter, my bad, thank you, Ms. Rogers. Solid is the first state of matter with liquid. Moving on up the energy scale, how the atoms are moving. Next up is gas, and then finally, plasma. As you can see, we have some indicators of what solid, liquid, and gas are. Solid, remember, is the slowest moving of all of the atoms. There's not a whole lot of energy there. But once we get enough energy, we move on to the next level, which is liquid. Then finally gas, and the most energy, plasma. Solids. Solids have a definite shape and volume. You can't really change a solid the way it looks without, just completely destroying it physically. The particles are tightly packed together because there's not a whole lot of energy. Not a lot of energy means not a lot of movement. Next up is the liquid. That is the next up in our energy change phase. They're moving just a little bit more so than the solids are. Liquids have a fixed volume but can change shape. If I have a bottle of Mountain Dew and I flip it around a little bit, you'll see that the liquid actually takes the shape of the container. It does in fact change its shape. And the particles are not as tightly packed together as a solid. Once again, they have more energy, so therefore there's more reason for them to flow. Here's a red one. That's a liquid. Gases. Gases are fun to talk about. Gases do not have a definite shape or volume. They basically take up whatever container space that they have. The gas is inside of inside of a small square container, it's going to take the shape of that small square container. If it's inside of a tire, like your parents drive with their car, it's going to take the shape of the tire. The particles are very loosely packed together. Because they're so incredibly loosely packed together, they have more room for energy and they move more. That means that they're hitting the sides of their container constantly. More energy means more movement. Liquids and gases both take up the shape of their container. Plasma, I adore talking about plasma. It's the most abundant phase in the entire universe. Oh, that's awesome that it came up right when I said that. Most common state of matter in the universe. Maybe not the most common on planet Earth, but definitely in the universe. Isn't that right, Ms. Rogers?
Yeah, because it makes up all the stars in the universe.
Which are very, very important. It is not commonly found on Earth.
It is, though. It's in our core, it's in lava, it's in lightning.
Yes, very much so. In our blood, did we mention blood already?
It's a different type.
Different type of plasma. Did you hear that, kids?
Same name, just to confuse you.
Thank you, Ms. Rogers. I'm sure they have the same problem, too.
Yeah.
Plasma is a gaseous mixture of electrons and positive ions. These electrons and positive ions, whenever they get in touch with any type of energy, that's when they start to react, and that's when we get to know things as a plasma, like lightning and so on. We need energy to flow through the plasma for us to actually see. Plasma is produced by heating a gas to an extremely high temperature. Classifying matter. Matter can be classified into the following three groups. The first one is elements. Elements, you know all about elements. Yeah, go ahead and show it over there. We have an entire periodic table full of them. Holy crap, that's a lot.
How many elements are on the periodic table?
Oh my goodness, I gotta find out. How many are there, Miss Rogers?
118.
Ah, good deal. 118. That's elements. They're only made up of one type of atom. Those are elements. Now, whenever we talk about compounds, that's a couple of elements put together, at least two or more. But we'll get more into that until later. And then mixtures. Mixtures we'll go over quite vividly in just a second. Elements, starting with the old elements. Elements are composed solely of one type of substance. For example, hydrogen is only made out of hydrogen atoms. Helium only made out of helium atoms. Carbon is only made out of carbon. Silicon only made out of silicon. You get the picture. They're not mixed together in any way. Elements are pure. They're on their own. Simplicity at its best. Examples of this would be iron, that's Fe. Actually, that comes from the old Latin name ferrous, which is where we get the name iron. That's how we got that symbol. Oxygen, and of course calcium, Ca. I know you already know Ca because you're studying very, very hard for it. Elements cannot be broken down any further. This is as simple as it gets. What's on that periodic table is as simple as it gets. It can't get any simpler. That's it. Compounds, a little bit more complicated. Compounds are composed of two or more elements. It could be maybe just carbon and oxygen put together, or it could be several of them put together. It could be 30 elements put together. A compound is just more than one element coming together. Compounds can only be chemically broken down into their component elements. So if something's made, let's say carbon dioxide, that's CO2, it can only be broken down into carbon and oxygen, nothing else, because that's all it's made up of is just carbon and oxygen. Examples, we've got iron oxide. It's got Fe2O3, you see that right there.
What's an example of iron oxide?
Okay, Ms. Rogers, iron oxide would be like, you see rust on your bicycle. When you come out in the morning, you see a little bit of rust on there. Maybe there's rust on your car or rust on a chain or something like that. That's iron oxide. That just means that the iron and the oxygen are breaking apart from one another. They're trying to break down themselves. Sodium chloride, also known as table salt, that can break down as well into just sodium and chlorine. And then one of my personal favorite compounds of all time, C3H8. Those of you that watch King of the Hill know exactly what propane is. C3H8. Once again, when we break that down, it's just carbon and it's just hydrogen. That's it. You can't break it down into anything else because that's all it's composed of. Mixtures. This is where we'll really start the party. Mixtures are a combination of two or more different types of matter. There are mixtures all around us. There may be a mixture of different types of snacks inside of your lunchbox. There are many different types of mixtures that we can go. The different forms of matter are not chemically mixed together. Mixtures are not chemically fused together. If they were fused together, then they would be a compound or something else. Mixtures can be separated through physical means. Can be separated. For example, if you had a mixture in a cup and it was sand and Cheerios, we could separate that by maybe using, I don't know, a sifter of some sort or a colander, like you separate your spaghetti noodles from your water. There's a way to physically separate them, and that physical separation is what defines a mixture. There are two types of mixtures. Homogeneous, homogeneous. Ms. Rogers likes to say homogeneous, which is correct. And then heterogeneous. Homogeneous or homogeneous means that it all looks like one complete item. It looks like the same throughout, whereas heterogeneous looks like there's different parts to it. Like if you picked up a box and it had Legos and potato chips in it, that is definitely a heterogeneous mixture because you can tell the difference between those two items. Now, a homogeneous mixture, that would be like Kool-Aid. If we looked at a Kool-Aid container, you can't see separation. It looks like, well, the same throughout. Homogeneous mixtures. Homogeneous mixture / solution appear to be composed of only one form. They look the same throughout, no matter what. There's not something floating around in it that you can see. Now we're back. But it looks the same throughout. It looks like one complete thing. They are uniform in composition, which means they look the same throughout. Uniform means same. Examples: blood, vinegar, air, Kool-Aid, hey, we already said that one, Gatorade, and unopened pop. These are all things that when you stare at them inside of a container, they look the same throughout. There's not different things floating around in them. You can't see little pieces of other things.
What if you could, like polluted air?
Well, then we could separate it out by physical means.
So would that be a homogeneous mixture?
Oh, let's think about that, Ms. Rogers. No, it would not. Ms. Rogers is looking at me and saying
It would not, because you could clearly see the different things. Maybe it was smog, or you could see the separation of the layers. So that would be different. So you have to be careful of how it's worded. This should technically say pure air or clean air or the air in this room, right?
Right.
Because we can't see. Just a heads up.
Thank you. Continue. A colloid. I actually really adore colloids. Colloids are pretty tasty, honestly, when you think about it. A colloid is a homogeneous or homogeneous mixture or solution with intermediate particle size between a solution and a suspension. In other words, it looks really foggy. Oh, where'd it go? There we go. In other words, colloids, they kind of look kind of foggy. There's a fuzziness between, like mayonnaise is a colloid, fog is a colloid, swimming pool water. If you put on your goggles and you go underwater and you look to the other end of the pool, you'll notice some floating effects and the light coming in. That's a colloid. It's fuzziness in the air, fuzziness in the solution. Examples, oh, where we go. Milk, fog, jello, and of course the swimming pool example. These all look foggy. Water looks foggy. Heterogeneous, a little different than homogeneous. Heterogeneous means that they're composed of
It's fancy.
Heterogeneous mixtures are composed of two or more different forms. When you look at it, you can tell there's definitely different things throughout it. Maybe we're looking at a bowl of cereal, my favorite cereal, Lucky Charms. You can see the rainbows. You can see the little little four-leaf
Clovers.
Yeah, you can see all those wonderful things. And you can tell there's a difference between them. They don't look like all one. They look like a whole bunch of little things together. You can definitely tell there's a separation. They are not uniform in composition. Not uniform means not the same. Examples include sand. When you look at some sand, you actually see little pieces of soil, you see little pieces of rock. There are things mixed in, and you can tell there are differences between every single grain. That makes it heterogeneous. Spaghetti sauce with meatballs. I'm getting hungry looking at this one. This is bad. Spaghetti sauce with meatballs, if we're looking at it, you can see the separation between the meatball and the spaghetti sauce. Pepperoni pizza, man, whoever made this. Pepperoni pizza, you can see a separation between the cheese and the crust and also the pepperoni slices. Mint chocolate chip ice cream, they decided to also go with dessert. That's awesome. You can see the little mint pieces mixed in with the different types of ice cream. Stew, there are definitely different parts to stew, especially the stuff my mama makes. Cereal with milk. Cereal with milk, you can tell a separation between the milk that it's sitting in addition to the wonderful little magically delicious pieces that we're eating. Blueberry muffins, you can see separation there. You can see the breading and the blueberries within. And of course, Chex Mix, the best example of all. If you ever eat Chex Mix, there's like 6 different types in there. They're all good. Be sure you skip the pretzels. Here's some spaghetti. Practice. Oh boy, now we get to practice together with Miss Rogers. Probably going to need her help. We're going to classify each of the following as an element, a compound, a heterogeneous mixture, or heterogeneous, or homogeneous or homogeneous mixture. First one, chlorine. Oh, oops, sorry. Chlorine. Now, chlorine, I remember that chlorine is one of the elements up on the periodic table. Miss Rogers showed you that earlier. I know you've probably been studying your elements vigorously. But chlorine cannot be broken down anymore. It is, in fact, an element. Chlorine is as simple as it gets. Water. Now, water is a compound, isn't it? Water is H2O. That means H2, meaning hydrogen, there's 2 hydrogens, and oxygen, there's only 1 there. So that's got to be a compound. That's 2 or more elements combined into 1. Now, soil, we've got to think about here. Now, soil, I can see separation in soil. I can see there's little pieces of loam. I can see bits of rock. I can see bits of the actual dirt itself. There's some separation there, and I can tell there's different parts to it. It's different, so that means it's probably a heterogeneous mixture. It's a mixture, and it's all different. Salt water. I'm going to let Miss Rogers explain this one, because she caught me on this one.
Salt water, it needs to be specific. So in this case, I'm talking about table salt, sodium chloride, NaCl, and water, H2O, put together. Salt will dissolve in the water, which makes it one uniform throughout. It just looks like water. And so it would be a homogeneous mixture. If I said seawater, like salt water from the sea, then you would have all different bits and pieces in there, and it would look like a different structure. So of course it would be different, a heterogeneous mixture.
Wonderful, thank you, Ms. Rogers. Next up, oxygen. Hey, I remember seeing that on the periodic table, and I remember I'm studying it too. I always study your elements. Oxygen, that is number 8 on the periodic table, so therefore that makes it an element. It's the simplest form it could possibly be in.
Oxygen is one of the most missed questions on this test because students often choose oxygen as a compound because they think we breathe oxygen, it's in the
okay.
air, and we have to remember it's as simple as it comes. It's just an element. Don't make that mistake.
Carbon dioxide, that's what we breathe out, what we expire, if you will. Carbon dioxide, that means there's 1 carbon and 2 oxygen. Hey, that's a compound. Both of those elements are up on the periodic table. Rocky Road ice cream. This is, I don't like Rocky Road ice cream, it makes me itch. Rocky Road ice cream, we can definitely tell that it is a mixture of some sort. We can tell there are different parts in Rocky Road ice cream. You have the peanuts and the marshmallows and the chocolate, so on and so forth. And we can tell the different parts, so it's got to be heterogeneous, meaning different. Kool-Aid. Kool-Aid, that is a mixture, but it's uniform throughout. It looks like just one type of drink. There's not a whole bunch of things floating around in there. There's not any separations. That's got to be homogeneous. Coffee. I'm going to let Ms. Rogers take over on coffee as well.
Coffee, on this, I'm specifically talking about black coffee. That's why it's just one word coffee, which it would be uniform throughout, therefore same, homogeneous mixture. If it said like an iced latte or a cappuccino or something with layers, I would be very specific to let you know, and of course then that would mean it's made up of different things and could possibly be a heterogeneous mixture.
Perfect. Thank you, Ms. Rogers. Oh, aluminum.
Aluminium.
Aluminium, if you're from England or the United Kingdom, that's how you would say it. Aluminum, that's one of those elements on the periodic table. Simplest form you can put it in, it's an element. Oh, here's a wonderful little scattergram, if you will, of everything we've went over today. Everything is matter that we do. Matter is made up, you're either a substance or a mixture. A substance is either an element, that means you're made of one type of atom, like carbon or gold or oxygen, vanadium, neon, magnesium, you get it. Compounds, that's 2 or more elements put together, married, if you will, in a relationship. Compounds include sodium chloride, which is table salt, H2O, which is water, or dihydrogen monoxide, however you want to look at that. CO2, carbon dioxide, A3SO2, aluminum and sulfur. You've got this. And that is about all that we have. Thank you very much. Ms. Rogers, do you have anything else to add?
We go back one more slide.
Yes, we will. Oh,
Homogeneous and heterogeneous.
completely forgot about that. Thank you, Ms. Rogers. Mixtures, there are 2 different types, homogeneous and heterogeneous.
Prefix HOMO means
Same,
prefix HETERO.
different.
That's all you need to know.
All right.
Bye. Till next time.
Bye-bye.